Hey guys, Mr. Milton here. Today we're going to talk about special parallelograms. At the end of this video, you should be able to use the properties of special parallelograms to find missing side lengths and angle measures. And you should be able to identify a special parallelogram by given characteristics. The last two lessons we've talked about the properties of parallelograms. Now we'll look at special parallelograms and the additional properties that go with them. Okay, so the special parallelograms, one, a rhombus. A rhombus is a parallelogram with four sides congruent. Move this up so I don't have to keep moving it. Okay, so a rhombus has four sides congruent. A lot of people get that confused with square. Please don't. We'll talk about a square in a little bit. A rectangle is a parallelogram with four right angles, 90-degree angles. And a square is a parallelogram with four congruent sides and four right angles. Okay, so a square has both four congruent sides and four right angles. Alright, so here are some properties, additional properties that we have to talk about. Okay, property one, each diagonal of a rhombus bisects two angles of the rhombus. Okay, so here we should see that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. Okay. Also, for a rhombus, the diagonals of a rhombus are perpendicular. Also seen as the upside down, capital T, perpendicular. Okay, and all that means is that they make a 90-degree angle when they bisect, or when they intersect, which they will bisect because they're parallelogram. Alright, again, we could prove these things out, show that it has to be true each time. I'm going to save you that here. Yeah. But the diagonals of so a rhombus has two special properties. The diagonals bisect two angles of the rhombus, and the diagonals are perpendicular. Okay, so that's in addition to all the other things that we've talked about with parallelograms, because the rhombus is a parallelogram, so it has that in addition to these two. All right, for a rectangle, the diagonals of a rectangle are congruent. The diagonals of a rectangle are congruent, meaning they are the same length. So here they say that FEDG is a rectangle, and they tell us that FD is 5x minus 3. D 5x minus 3. And they tell us that GE is 3x plus 9. Alright, so given those two diagonals and what we know about the diagonals of a rectangle, we know that diagonals of a rectangle are congruent. So 5x minus 3 must equal 3x plus 9. And so now this is a problem that we can solve just because we can set it up knowing that the diagonals of a rectangle have to be congruent. So now we solve. 2x equals 12, divide by 2, x is 6. Okay, so we find that x is 6, and we can solve that GE should be 27. That's 30 minus 3 is 27. I know that's FD. 18 plus 9 is 27. Good way to check our answer just to make sure it works out for both, since we know they're congruent. Alright, so again, this is in addition to the other properties of parallelograms that we've already talked about in previous lessons. Alright, let's talk about this really quick. You'll notice that we didn't really stop and give square its own section. When we talk about these special parallelograms, notice that a square had the properties of a rhombus and a rectangle. And so a square and a square, all these will be true. In a square, it has each diagonal bisects two angles. The diagonals are perpendicular, as well as the diagonals being congruent. Okay. All right. So here's some converses. And remember, converses, we're just flipping the hypothesis and the conclusion. And so, if one diagonal of a parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus. So this is us not knowing that the parallelogram, what exactly it is at first. If we see these extra or additional properties which deal with the diagonals, then we will be able to tell which figure it is. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Again, guys, notice that there's no square classification here with these individual properties. Okay, what we can tell is a square. When we can tell it's a square, it has both properties of a rhombus and properties of a rectangle. So, for instance, if I saw that I had congruent diagonals that bisected two angles of the parallelogram, then I'd say, oh, it's a rhombus. Oh, and a rectangle. That must mean it's a square. Okay? So, notice with the converses, we are given, or we start with a diagonal with certain special characteristics, and we conclude that is one of the special parallelograms. Alright, so there you have it. Those are the special properties, special parallelograms. See ya.